and go back and go back and go back until you really understand it. You go through 2 full high tide periods, 2 full low tide periods, from a dark of the moon to full of the moon. The moon influences the tides, and you know, it's different every day. It's the same, but it's different every day. Every beach has a secret, and if you're persistent enough to stay with it and figure it out and find the key and unlock that lock, and you get that treasure, wow, I mean, it could really be neat, and you've done your thing. And every day you can find that secret and get that treasure.
To help us get started, once again, here's Lance.
Hi. Now that we've got this machine together, we're going to show you how easy it is to use it. First off, we'll take our gain control and turn it all the way over. Then we'll take our tuner and we'll turn the tuner down to where we just have a faint sound. We'll take our headset and put it on and readjust the machine just a little bit to where it's really fine-tuned. And then we're ready to hunt on the beach. We can take and show you the sound that we're going to have with a target. I have a gold ring here that I found on the beach a couple of years ago, and the distance that you can hear this from the loop is really amazing. I can get it out to 10 and 12 inches and still hear the target.
Let's watch as Lance demonstrates proper technique in beach hunting. Notice how Lance covers a lot of ground with a smooth, steady sweep. Also notice how the loop's path overlaps so as not to miss any area, and also pay attention to how the loop stays level with the ground. Even with the loop submerged, Lance maintains a consistent sweep pattern. Lance makes short order of digging with his mesh scoop, all the while scanning the hole to pinpoint his target. Some additional scooping, and Lance has another prize find. Let's get back to Lance and learn a little bit more about the Surf PI.
Before we go any further, we're going to tell you some more about the individual controls of this machine. And for that, we're going to have Dan Geyer, the White's engineer, take it from here.
Hi, I'm Dan Geyer. I'm the project engineer on the new Surfmaster PI Pro. When we decided to update the PI machine, customers are contacted to find out what they would wish as far as added advantages. The 2 things that came back as requested were basically more sensitivity to small objects excuse me, and deeper depth detection. So with these 2 goals in mind, we went on to design the new detector. The PI detectors basically work by running a current through a search coil, which establishes a large magnetic field around it. The transmit pulse closes a switch and runs a current of electricity through the search coil. After a short delay, that thing is opened up again, and the magnetic field that's been established around the coil suddenly collapses. As it collapses, any metal nearby will have additional currents induced in the surface. These currents tend to make the field collapse over a longer over a longer period of time, and this delay is measured and converted into an audio signal that you hear in the headphones. The sensitivity is established in 2 ways. The overall gain of the system that takes the signal from the search coil establishes the minimum signals that you can hear. The sampling mechanism that is used also establishes somewhat the sensitivity of the device to different kinds of metal. Let me erase this here. When the transmission pulse is turned on, current starts to flow through the coil. When the current is turned off, the magnetic field collapses back around the coil and induces a very, very large flyback pulse. This flyback pulse is what's establishing the eddy currents in the metal targets. We have a sample pulse that looks at the return signal during this period of time here. And what happens when metal comes into the field, this curve in the received current actually varies as the metal moves through the field and comes out again. We're looking at this area specifically for these changes, and that's what's converted into the audio signal that you hear. There's a second pulse that shows up out here, and this area is long after this initial transient performance here. This pulse is used as a reference to compare this changing pulse to a somewhat steady pulse in the circuitry downstream. That voltage that's developed between those two pulses controls the audio that you hear, and it's what's used to indicate whether the metal is there in the field or not. With the new PI detector, to increase the sensitivity, we've increased the overall gain, and we've moved the position of the sampling pulse. On the original detector, there was a gain, or the phase compared to the falling edge here, of about 20 microseconds. That's 20 millionths of a second. We have moved this now to a sampling point of 15 microseconds. What that does is increases the overall sensitivity to very small pieces of jewelry, deeper buried coins, and also gold will show up easier with a shorter delay than it would with the previous model. Now that's just the sampling. We've also increased the overall gain of the system. I have an amplifier, a coil, a switch, a power source, and then the headphones.